A supermassive black hole is depicted in this artist's concept, surrounded by a swirling disk of material falling onto it. The purplish ball of light above the black hole, a feature called the corona, contains highly energetic particles that generate X-ray light. The corona gathers inward, becoming brighter, before shooting away from the black hole. Credit NASA's occult how was light able to burst out of the gloom of the cosmic dark ages, approximately 500 million years after the Big Bang. New research may provide insight into one of the universe's longest-standing mysteries, and the surprising hero in this story might be everyone's favorite astronomical villain: black holes. The story starts within the fractions of a second after the Big Bang, when the universe expanded exponentially. It became a cosmic soup of fundamental particles that cooled relatively quickly in about 400,000 years, creating a dense hydrogen gas. This began what is known as the cosmic dark ages, during which the universe was shrouded in murk. Any light emitted by early stars and galaxies would have been almost immediately absorbed by the surrounding thick neutral hydrogen medium. But somehow, the intergalactic medium changed from being cold and neutral to become warm and ionized. Cosmologists have theorized that enough intense ultraviolet light was provided by early stars and galaxies to burn off the dense hydrogen, sparking the epoch of ionization that transformed the universe into the light-filled marvel we know today. How this happened is not well understood, as other theories say the UV radiation from the stars and galaxies in the dark ages would not have been powerful enough to blow through the neutral hydrogen. But a new study of recent observations by the Chandra X-ray Observatory, whose results were just published in the journal Monthly Notices of the Royal Astronomical Society, might provide a clue. Related, Hubble has found the ancient galaxies that gave the universe its first light. While black holes are famous for devouring all the light and matter around them, some of them are known to be spitting out powerful jets of high-energy X-ray particles. As matter falls into a black hole, it starts to spin, and the rapid rotation pushes some fraction of the matter out, said lead author Philip Carrot, from the University of Iowa, in a statement. They're producing these strong winds that could be opening an escape route for ultraviolet light. That could be what happened with the early galaxies. Carrot and his team looked at Chandra data from a galaxy called Tal 1,247,232, located about 600 million light-years from Earth. It is one of only 3 nearby galaxies from which ultraviolet light has been found to escape. In May 2016, Chandra observed a single X-ray source from Tal 1,247,232 whose brightness waxed and waned. Carrot and his colleagues determined the source couldn't be a star. Stars don't have changes in brightness, said Carrot. Our sun is a good example of that. To change in brightness, you have to be a small object, and that really narrows it down to a black hole. Jets of X-ray material shooting out from the black hole appear to have blown out cavities in the nearby gaseous medium, allowing the UV light to escape. It's possible the black hole is creating winds that help the ionizing radiation from the stars escape, Carrot said. Thus, black holes may have helped make the universe transparent. Related, this is our amazing Technicolor cosmos. He compared the process to a figure skater spinning with outstretched arms. As the skater brings her arms closer to her body, she spins faster. Black holes operate in a similar fashion. As gravity pulls matter inward toward a black hole, the black hole likewise spins faster. As the black hole's gravitational pull increases, the speed also creates energy. As in Tal 1,247,232, the blasts of X-rays in the early universe would have had enough heat and energy to blow the neutral gas and dust away, the team said, allowing the ultraviolet radiation to leak out. Carrot explained in an email to Seeker that many of the early stars in the universe were massive. These stars age very quickly and die as black holes, he wrote. The stuff around black holes is very hot, millions of Kelvin, and creates X-rays. Then the UV in the story comes from hot stars, and is 10,000 S to 100,000 S of Kelvin. Related, astronomers are attempting to capture the first ever photograph of a black hole. While black holes are the likely mechanism, the team would like to narrow down the type of black hole. They also said there are still other possibilities to explain their observations. Another possible origin of the X-ray emission, the team wrote in their paper, is from an ultraluminous ULX or hyperluminous HLX X-ray source. ULXs are thought to be X-ray binaries that contain stellar mass black holes or neutron stars. HLXs may be super-Eddington accretors, possibly quasars or intermediate mass black holes. They said that repeated X-ray imaging of Tal 1247 with Chandra could reveal whether the X-ray emission arises from a single source or multiple sources. Additionally, the team has been looking at a similar galaxy, Haro 11, and said that since it is not possible to draw robust conclusions from a sample of two objects, they hope to be able to observe more galaxies where jets of material shooting out have blown out large cavities in the surrounding gas. Originally published on Seeker.